Today we're going to be working on solving systems by substitution, day number 4. Our content objective is students will be able to solve a system of 2 equations by the substitution method. Our language objective is students will be able to discuss ways of checking if the solution you derived is truly a solution. And why am I learning this? Well, it's important for real-life problems like finding the best value among high-speed internet providers. So first, let's go over some background knowledge. We've gone over this type of problem in the past, but let's go ahead and remind ourselves how we did it. So it says here, Jenna is deciding between 2 cell phone plans. The first plan has a $50 sign-up fee and costs $20 per month. The second plan has a $30 sign-up fee and costs $25 per month. For how many months will the cost be the same? So they're trying to figure out when is it going to be the same. So I'm going to set them equal to each other. The first plan is $20 per month, so I'm going to go ahead and say 20x, where x, of course, represents the number of months. And on top of that, you are paying the $50 sign-up fee, so I'm going to add 50. Now, for the second plan, it's a $30 sign-up fee, and it costs $25 per month. So I'm going to do 25 times x to represent the $25 per month, plus the sign-up fee, which is $30. So here, if I wanted to figure out when the cost will be the same, I'm just going to go ahead and solve for x. In this case, since we do have variables on both sides, I'm going to go ahead and move my variable over to the left. So I'm going to go ahead and subtract 25x from both sides, leaving me with negative 5x plus 50 equals 30. Now, in order to isolate x, I'm going to subtract 50 from both sides, leaving me with negative 5x equals negative 30. Now, all I need to do is get rid of your coefficient by dividing both sides by 5. Negatives cancel each other out, leaving me with x equals 4. So here, since x represents the number of months, which I defined it to be that, in order to answer the question, it says, after how many months will the cost be the same? I will say the cost will be the same at 4 months. And there's your answer. Okay, so now let's kick it up a notch. What if I ask the same exact question, but I want you to solve it using a system? What could we do? Well, the first plan, if I said, okay, x is going to represent the number of months and y is going to represent the total cost, what would I do? Well, I would recognize that that would be y equals, let's see here, the $20 per month, so that's still 20x, plus your $50 sign-up fee. And then the second plan would be y equals, because the total cost would be the first $25 per month, so 25x, plus the $30 sign-up fee. And there I have 2 equations. So in this case, how would I solve it? I do have a system because I have 2 equations. Well, remember how I told you you at least need 1 variable that's solved for? We have that. In fact, we have 2. So what I'm going to do is I'm going to go ahead and take this value here and substitute it in for y. So here I'm going to be left with 20x plus 50 equals 25x plus 30. Same idea here. Since we have variables on both sides, I'm going to go ahead and move it over to one side. I normally move it to the left, but you could always move it to the right if you choose so. Still leaving me with negative 5x plus 50 equals 30. Same idea, get rid of your constant, leaving me with negative 5x equals negative 20. Last but not least, we're going to divide off this coefficient, leaving me with x equals 4. So guess what? For the first question, how many months will it be the same? It's going to be the same answer. Cost will be the same at 4 months. But for the second part, what will the cost be? Well, since they're going to be the same, I can use the first equation or the second equation, whichever is easier. I think the first one's a little bit more simple, so I'm going to go ahead and utilize the first one. So The cost, which is y, is going to equal 20 times x, which I determined to be 4, plus 50. So this is going to be 80 plus 50. So 80 plus 50 is going to be 80 plus 50, $130. So what will the cost be? The cost will be $130. There you go. You went ahead and answered both questions. So here, notice you could have also solved it using a system. Okay, so let's go ahead and practice that. So in the past, when we're using substitution, we've always wanted at least one variable to be solved for. In this case, we have two. So what do? Same thing as we normally do. First, I like to write them side by side. Y equals x plus 2. Here, y equals 2x minus 1. Since I know the value of a y, I'm going to go ahead, take it, and substitute it in for y because it's y equals. So now I'm left with x plus 2 equals 2x minus 1. So now what you're going to do is, since we have variables on both sides, you have to move it to one side. I normally move it to the left, but again, if you wanted to move it to the right, you can as well. So now I'm left with negative x plus 2 equals, this goes away, leaving me with negative 1. Subtract 2 from both sides. Negative x equals negative 3. Last step, divide off that negative 1. And I'm left with x equals 3. However, you know I'm not done. I need to go ahead and substitute this back in. So I'm going to go ahead and substitute it in for x, which leaves me with y equals 3 plus 2. So y equals 5. So now I can go ahead and write my solution, which I've come to the conclusion I think it's 3, 5. And you know that I claim to think that's the solution because I haven't, of course, checked my work. So let's go ahead and quickly check our work. First, just a quick reminder, the x values are 3 and the y values are 5. So here we have 5 equals 3 plus 2. Is this true? Yes. So it works for the first equation, but we're not done. We have to check the second equation as well. So here, 5 equals 2 times 3 minus 1. Is this true? Yes, it also works. So I can confidently say the solution to this system here is indeed 3, 5. Okay, so now moving on to the next example, I would like you to go ahead and pause the video and try this one on your own. Okay, so let's see how well you did. First, we always need to check, do we at least have one equation that's already solved for? Here, we conveniently have both of them that are solved for. So, what we're going to do is go ahead and write them side by side. Y equals 2x plus 3, and y equals negative 2x minus 9. Since I know the value of a y, I'm going to go ahead and take this expression and substitute it in for y. How come y? Because here it says y equals. So I'm going to be left with 2x plus 3 equals negative 2x minus 9. So here, since we have variables on both sides, I'm going to go ahead and move it over to the left. Now here, hopefully you were careful and you put plus 2x to both sides, and you're left with 4x. Some students may have the tendency to make a mistake on the step and somehow get 0x, so just be very careful. So here we have 4x plus 3 equals, this goes away, negative 9. So you're going to subtract 3 from both sides to get rid of that constant, leaving me with 4x equals negative 12. Last step, get rid of your coefficient by dividing, and x equals negative 3. But we're not done. We're going to take this value and substitute it back in for x. So we have y equals 2 times negative 3 plus 3. So now we have y equals negative 6 plus 3. Last but not least, y equals -3. So I think the solution is the x, which is -3, comma the y, which is also -3. But again, we don't know for sure yet. We just think this because, of course, we haven't checked. So let's go ahead and check our answers real quick. Here, this is the x, this is the y. In this case, they're both the same. Doesn't really matter. -3 equals 2 times -3 plus 3. -3 equals -6 plus 3. -3 equals -3. This is true, so it works for the first one. Here, -3 equals -2 times -3 minus 9. -3 equals 6 minus 9. -3 equals -3. So since it works for both, I can confidently say the solution to this system is indeed -3, -3. Okay, so now moving on to something very similar. Now, what if both of the equations are not solved for the same variable? Well, in that case, why not make both of them the same? So in this case, this one's already solved for y, so all I would have to do is solve this one for y as well. So here we have y equals 2x, which is great, but for this one, x plus y equals 6. This one's not solved for y, but we could change that real quick by simply subtracting x from both sides, which leaves me with y equals -x plus 6. So I know what you're thinking. Some students are thinking, well, how come here we already know that y is already solved for? Why don't we just take the 2x and substitute it in for y? That is true. That will also work. But I want to show you this method as well, because some of my students have the tendency that when they substitute it in, they don't distribute correctly or they don't combine like terms correctly, and it's probably not the best method for them for that reason. This method makes it a little bit easier in the sense where you don't have to distribute and you don't have to necessarily combine terms. So watch. Here, since both variables are solved for, simply take this 2x and substitute in for y. Again, y, and not x, because here it says y equals. So here we have 2x equals -x plus 6. Notice here I do not have to distribute. I don't have to combine like terms. So in this case, I'm going to go ahead and move my x over to the left, leaving me with 3x equals 6. Now divide both sides by 3, and I'm left with x equals 2. Now that I know what the value of x is, I'm going to go ahead and take it and substitute in for x here. So I'm left with y equals 2 times 2. So here y is 4. So now that I know the value of x, I know the value of y. I can go ahead and write my solution. X is always written first, so that's 2, comma, y, which is 4. So I think the solution is 2, 4, but let's go ahead and check so we can confirm. So here, reminding ourselves our x's are 2's and our y's are 4. Let's see. 4 equals 2 times 2. This is completely true, so that works. Here, x is 2, y is 4. This is completely true as well, so it definitely works for both. So, one thing again that's nice about solving for a variable to use substitution in this way is it's nice because it kind of takes away the distributing aspect and the combining like terms. Will it always be the case? Not necessarily, but for the most part, that's what you're going to see. So now what I would like you to do is go ahead and pause the video and try this problem by yourself. Okay, so let's see how well we did. Again, we at least want one of the equations solved for. In this case, we have y solved for, y equals 4x. Now for the next one, it's not exactly solved for, so let's change that. We have 2x plus y equals 6. So in order to solve for y, because we need them to match, you can't simply just solve for x in this case, I'm going to go ahead and solve for y by subtracting 2x. leaving me with y equals negative 2x plus 6. So that's something I want to mention real quick because I forgot to stress this. When we're doing this method, you want to make sure you're solving for the same exact variable. Don't have one solved for x and the other one solved for y. That would not be wise. Okay, so now I know the value of y is 4x, so I'm going to take this expression and substitute in for y, again because it's y equals. So now I'm going to be left with 4x equals negative 2x plus 6. Notice here, I do not have to distribute. I do not have to combine like terms. All I need to do is move my variable over to the left by adding 2x to both sides, leaving me with 6x equals 6. Now dividing off the coefficient, I'm left with x equals 1, but I'm not done. I need to plug that in for x. So that means y equals 4 times 1, so y is 4. I know the value of x, I know the value of y, so I can go ahead and say that the solution, well, not say, I think the solution is 1 comma 4. You know I say think because we still need to check our work. So let's quickly check our work, where in this case x is 1, y is 4. We have 2 times 1 plus 4 equals 6. We have 2 plus 4 equals 6. This is true, so it works for the first one. Here we have 4 equals 4 times 1. This is also true, and because it works for both, I can confidently say that the solution to this system is indeed 1 comma 4. So that's going to conclude our lesson for today. Thank you so much for tuning in. And as always, until next time, bye.